All right, ladies and gentlemen, we are ready for lesson 8-2, equivalent fractions using number lines. And we have to be able to name the same amount on a number line using equivalent fractions when we're done with this lesson. So I want to look at the solve and share first in this yellow ruler that you see in front of you. So I am on page 417. Make sure that's where you're at as well. It says, suppose you have a ruler showing fourths. So first I want to take a look at that first line here and show you that each piece is a fourth of an inch. There's 4 sections. So there's 1, 2, 3, 4 sections. And if I keep going between inch number 1 and number 2, there's another 4 sections. But I want to just look at the first inch here today. So when it says, suppose you have a ruler showing fourths, what they mean is each of these sections is a fourth of an inch or a quarter of an inch. It says use your ruler to name a fraction that is equivalent to 2/4. So you notice that there's a red dot at 2/4, and they want us to figure out a fraction that's equal to this fraction 2/4, and then tell how you know the fraction is equal to that. So what I'm going to show you is that the same thing we did yesterday we can do today. It's a little trickier because it's so small, but we can take, like we did with our rectangle. Yesterday we started with fourths, and we can shade in 2/4. And we can take this rectangle and we can break it apart, just like I'm going to show you how to break apart the inch here. And yesterday what we did is we took each section and we divided it in half. And when we did that, when we took fourths and we divided them in half, we ended up with 1, 2, 3, 4, 5, 6, 7, 8 sections. So we started with 2/4, and then we broke it in half, and we ended up with eighths, and we ended up with 1, 2, 3, 4 eighths. So what you're going to see on the ruler here in just a second is that I'm going to show you the same thing. We're going to end up with an equivalent fraction of 4 eighths. But on the ruler, if we do that, we need to section each piece in half. So I'm just going to do my best to kind of aim for the halfway point between each section and make a red line. And now instead of 1, 2, 3, 4 sections, I have 1, 2, 3, 4, 5, 6, 7, 8. The same thing I would have up here. And each section would be an eighth. So this would be 1/8, then 2/8, then up here 3/8, and then 2/4 would be 4/8. That's why they're equivalent, right, over here. And then I would have, I'm going to write it up here, 5/8, and then 6/8, and then 7/8, and at the inch mark would be 8/8, which makes sense because anytime our numerator and denominator match, it equals 1 whole, and in this case, 1 whole inch. Okay? So when they ask us to find an equivalent fraction today, they're going to be looking at a number line, and that's why they're showing you a ruler, because a ruler is a sort of number line. All right, let's head to the back side. Flip it over with me, and let's look at the situation we've got going on here. Sal rode his bike 3/4 of a mile or 3/4 of a mile to school. Name 2 fractions that are equivalent to 3/4. So you can see here first they show you him riding from home to school and the fact that that distance is 3/4 of a mile. Then they show you using a rectangle. So like yesterday, they broke each piece into a fourth, right? They broke it into 4 pieces, and they shaded in 3 of them because your numerator is how much is shaded and your denominator is how many pieces total. And then they're showing you underneath that rectangle a number line. Notice how the start of the number line and the end of the number line are the same distance as this rectangle up here. Something important that you need to remember is that when you're using number lines to show equivalent fractions, just like these number lines that you see down here that we're going to talk about in a second, they're all the same size. They have to be the same size, or else you cannot compare the fractions on them. Okay, so you're going to be comparing different pieces if your number lines are not the same size. So remember to keep your number lines the same size when you're showing equivalent fractions. Okay, on this number line, they've highlighted, or with a red dot, 3/4 of a mile. Here they colored the pieces in. So let's move down to this first number line, okay? It's the same as the one up here, just in a smaller scale. So they again have highlighted 3/4 of a mile. And then what they're showing you next is to divide these fourths, just like we did on our ruler before, into two equal parts, which are halves, right, to show eighths. So when you do that, right, when I separate these fourths in half, I make 1, 2, 3, 4, 5, 6, 7, 8 pieces, which again are highlighted down here. If I would match these up, right, if I draw my line the best I can straight down, right, they match up. So this up here would be 1/8, and then 2/8 or 1/4, 3/8, 4/8 or 2/4, 5/8, 6/8 or 3/4, 7/8, and then 1 whole is 8/8. So what that shows us is that 3/4 is also the same thing as 6/8. So if we want to give someone another way of saying how Sal rode from home to school, we could say he rode 6/8 of a mile. We could say 3/4 of a mile, because they're equal to each other. All right, so then what they did in the next number line is they took this first section, these fourths, and they divided them into thirds. So instead of dividing them in half like I did up here to show you the eighths, they took each fourth, right? This is a fourth. I'm going to make a jump to show you. This is a fourth. This is a fourth, and this is a fourth. And instead of dividing it in half, they divided it into thirds. So now there's 3 pieces. And each piece becomes a 12th because there's 12 total pieces. I'll show you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So each notch is now a 12th. So if you look, you can see where they match up. Obviously, 0 matches up. We don't have anything match up again until we get to 3/12. Once we get to 3/12, we see that 1/4 and 2/8 are equivalent to 3/12. And then we don't match up again until we get to 4/8, 2/4, and 6/12. Those are all equal to half, right? And then we match up again, which they've already circled, when we get to 3/4, 6/8, those are equal to 9/12. And then obviously we match up again when we get to 1 inch, or sorry, in this case, 1 mile, sorry. All right, so that shows us that Sal rode 3/4 of a mile, 6/8 of a mile, or we could say 9/12. And that's why you're seeing down here that they're writing that those fractions are equal to each other. So today you're going to be looking at a number line to decide if fractions are equivalent. I'm going to remind you again that the number line, if you're using that, if you're drawing a number line to show equivalent fractions, it must be the same size. Otherwise, it won't work. All right, let's move on. Grab page 419, please. And we're going to take a look at the guided practice. And we're going to start with the do you know how. So let's look at numbers 2 and 3. We have write an equivalent fraction for 1/3, write an equivalent fraction for 1/2. So if we look at the number line that they've given us, we can notice a couple things. They've already put 1/3 and 1/2 on there for us. But we don't have any equivalent fractions down below that match up with them. But what I'm noticing is they also, underneath the number line, have decided to tell us that these pieces are each a 1/6 of the number line. So if you look, you have 1, 2, 3, 4, 5, 6 total pieces. Now, yes, they're already marking this as 1/3 of that number line, but we have to figure out what 6th it matches up with. And that's pretty simple, right? We just go in order: 0 and then 1/6 and then 2/6. You should be filling this in alongside me, by the way. And then 3/6, 4/6, 5/6. This would be 6/6 or 1 whole. So if we go to answer this question, write an equivalent fraction for 1/3 on this number line, it would be 2/6. And 1/2 matches with 3/6. All right, let's jump down below. We're not going to use the first part of the independent practice, and I'll tell you why. We haven't talked a lot about mixed numbers or improper fractions. And once we hit 1 on this number line, we're moving into mixed numbers and improper fractions. And I don't want to confuse you yet, so we're not going to take a look at that right now. But we are going to go down to the bottom, okay? And I'm going to do the first one with you, and then I'm going to ask you to help me out with number 7. So the first thing we want to do when we're given a number line is figure out how many pieces it's broken into, because we're working with fractions. So the best way to do that is to make these jumps, all right? So if you start at 0, you don't count 0 as 1. Obviously, it's 0. So you're going to count each time you jump. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that this is broken into tenths. So I'm going to make sure that I write that in my denominator so I don't forget that there are 10 pieces here. You can notice this black dot here. So we need to figure out where is this black dot in regards to the tenths. Here's 1/10, 2/10, 3/10, and 4/10. So we have the black dot is at 4/10. It wants us to write 2 fractions for the point on the number line. So we can call it 4/10, but we also need to figure out what equivalent fraction works with this, and we can rename this and call it something different. So one way we can do that is by multiplying, right? So yesterday we talked about multiplying by a fraction that has a numerator and denominator that are equal to each other so that we can find an equivalent fraction. So let's say we put 2 here, because you want to aim for smaller numbers right now just to make it easier on yourself. So we would start by multiplying the numerator. 4 times 2 is 8. And then the denominator, 10 times 2 is 20. So we could call this point 4/10, but we could also call it 8/20. And if we wanted to show this on the number line, we would have to break each section in half. And that's kind of tricky when it's small like that. So I'm not going to do that to get you confused on the number line. But it would show 8/20 if we broke each of these pieces in half. Another way we can do this is by taking 4/10 and dividing by the same numerator and denominator. So again, I'm just going to use 2. If I divide 4 in half, I get 2. If I divide 10 in half, I get 5. So 4/10 is equivalent to 2/5, and it's also 4/10 is also equivalent to 8/20. So you can find equivalent fractions using this number line, but you can also use multiplication and division, which we'll practice more, but I find it easier to do it that way, okay? All right, so we're ready for number 7. I would like for you to figure out first what our denominator is that we're working with. And you're going to do that, remember, by making the jumps. Go ahead and do that now. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Hopefully you came up with a denominator of 8 because there are 8 pieces. Now I want you to figure out what is our black point lying at as far as eighths are concerned. So how many eighths is this black point representing? All right, hopefully you said 2. Now we have to figure out 2 fractions that are equivalent to 2/8. So the first way I want you to do that is by multiplying. And I want you to use 2. Go ahead and solve. All right, you should have come up with 4/16. Okay, another way we can find an equivalent fraction is, and I'm going to go up here this time, by dividing. So this time I want you to divide by 2. Go ahead and solve and tell me our new equivalent fraction to 2/8. All right, you should have divided to get 1/4. So we can say that 4/16 and 1/4 are both equivalent to our point right here on the number line, which is started with 2/8. Okay, let's turn it over. I would like for you to look at number 8. And we're going to start with what equivalent fractions are shown by the 2 number lines. So when you're looking at 2 number lines, the first thing you want to make sure is that they're the same size. Are these number lines the same size? Yes, they are. So we are going to look at fractions that match up. We don't want to match up a fraction going diagonally, right? It has to be a perfect line straight down on the number line. So there are 2 examples of equivalent fractions on these number lines. I want you to list both pairs. All right, you should have found that 2/4 is equal to 3/6. Again, we can draw lines straight down and match them up. And the other pair you should have found are 4/4 and 6/6. Remember that when you have the same numerator as denominator, they equal 1. All right. Let's move on. Okay, let's look at number 10. Jared says these number lines show 3/4 is equivalent to 2/3. Is Jared correct? Explain. So the first thing I want to look at is, do these number lines match up? Are they the same size? Hopefully you said no. You can tell because this number line ends here, and if I draw a line as straight as I can down, this bottom number line is larger. So when I go over here to explain, my first explanation, or part of my explanation, should be that the number lines are not the same size. So I know that 3/4 is not equal to 2/3. But then if I want to go further, how else could I explain that 3/4 is not equal to 2/3? How could I show that with numbers? All right, you might have decided to come over here and list 2/3 and maybe multiply by 2 and show that you would get 4/6. Is that 3/4? No. Then you could also talk about the fact that you can't take 2/3 and divide it, right? You can't make it smaller because 2 and 3 are not divisible by the same number. You could have also started with 3/4 and multiplied by 2 to get 6/8, which is nowhere near 2/3. Your examples are your proof or your explanation that these fractions are not equal to each other. Okay, you cannot multiply something by 4 to get 3, and you cannot multiply something by 3 to get 4. Same thing for our numerators. So that could be part of your explanation. All right, it's time to start the practice buddy, and then once I stop you, you're going to start the homework page.